This evening we're going to present eco-friendly options for a warm winter home. My name is Heather Deshanes. I'm from HND Architects. We also have Jack Piccarello sitting down here from JN Piccarello Construction. We have Pam DiVenuti from Pella Windows and Doors, Ray March from March & Martin, Steve Hergott from Uptack Plumbing and Heating, Ryan Fitzsimmons from Sunlight Solar, and Kimberly Collins Germain, who is a color design consultant. So what are eco-friendly or green building materials? Eco-friendly or green building materials are those that use resources in an environmentally responsible way. And there's many different factors that make a product eco-friendly. If it's made with salvaged or recycled material, it can be eco-friendly. If it conserves natural resources, it could be eco-friendly. If it avoids toxic or other harmful emissions like off-gassing, it's eco-friendly. Products that conserve energy or water, which we're going to hear a lot about tonight, and anything that can contribute, or a specific product that contributes to a safe, healthy indoor environment, also is defined as being eco-friendly. And why would you choose an eco-friendly product? Everyone's going to benefit from using eco-friendly or green products. The workers, especially the contractors and construction workers, are going to benefit, as well as the workers in the manufacturing facilities, because they're not going to have to use special equipment and they're not going to be subjected to harmful chemicals, gases, and dusts. Homeowners and people who live with the products are directly benefiting from the cost savings on the operating and maintenance costs, and they also live in healthier indoor environments. And then the environment is the biggest benefactor because it's protected from ecological stresses and contaminants. But there's other aspects than just the green building products. We also need to think about the entire package. So we need to think about energy efficient design and construction. So we want to think about where we're locating the windows. We want to think about the insulation and what type of insulation, which we're going to hear about tonight. We're going to think about air leakage and the best systems for heating. We also want to consider home size in comparison to our needs. So we don't want to build larger than what you realistically need, because that can save you money and energy by downsizing and using less materials. You also want to consider where the home's built and its site orientation. And you also want to think about design and construction detailing to avoid moisture problems. So you need to think about more than just the product. You need to consider the product and the entire package and make conscientious decisions that are going to benefit the environment and yourself in the long run. And next we have Jack Piccarello.
I'm a contractor and a home inspector. I've been in business for about 33 years. The business has changed, dramatically since I started. When I started, when you did demolition, you dumped debris anywhere you wanted. I remember taking truckloads of roofing shingles to somebody's yard and filling the backyard with them. I mean, it was I don't know if it was acceptable, but people regularly did it. That's all changed. We pay a lot of attention to where we get rid of things, how we dispose of things, and how we reuse things. There's a pretty good network of people through contractors, and you just kind of put the word out that you're going to be dismantling Mrs. Brown's kitchen, and it was only put in 5 years ago, and many times we can find a home for those things, and it happens a lot. Windows especially. We find a lot of people who are going through a major renovation. You know what it is. But they have gone through one 5 or 8 years prior, and the windows are all still in great shape. So they end up in vacation homes. They end up in income properties and things, and they get reused. A lot of that stuff gets reused. Also, from the very beginning, when we start excavating, concrete all goes to a plant to be recycled, and we buy it back as base material. Same as asphalt does the same. So it gets reused, and it's not perfect for everything, but it's our job to try and decide where we can use it. And we use a good amount of it because it's less expensive, and under certain things, it's a perfect substrate. So, you know, we're very conscious about the way we try and get rid of things, and it benefits us too, because it's less expensive for me to give something away than it is to pay to send it to a landfill. So it's a little bit of a good business decision too. You know, as a general contractor, you know, the house has changed, because in the 30 years I've been doing it, the house is more like a machine now, and those are the words of Heather, but it's true. There's so many mechanical things in the house now that it's our job to kind of integrate. We bring all these experts in, and they're great at what they do, but it's still our job to try and bring the whole thing to closure. You know, higher end heating options, raised foam insulation, it's a great product. It doesn't always fit everyone, it doesn't always fit everybody's budget, so we try and put it where it's most important. And maybe somebody can't afford to do radiant heat in their whole house. Maybe they can do it in their bathroom, in their kitchen. Or, maybe they can't do foam in the whole house. Maybe they can do it in a place where it would prevent needing a ridge vent or something that's problematic. So, you know, we have a good general knowledge of all of the trades, but we rely on these experts we try and decide and communicate regularly with the owners and the architect, and decide if we should maybe be heading down another direction as the project progresses, especially on renovation work, because conditions change every day, all day long. And you know, things you thought you could do, maybe you can't, but maybe opportunities arise that you weren't expecting, and we can head down those roads. We're also carpentry contractors. That's our primary business. And that business has changed dramatically too. We didn't used to pay as much attention to sealing buildings up as we do now. We don't, even in the framing phases, we're sealing sills really well. We're sealing, you know, on the water. We're paying a lot of attention to details as far as that goes, as far as house wraps, as far as taping house wraps. Most of the windows we install are finned windows, and the proper taping of those to prevent air infiltration. It used to be kind of quick. You threw tar paper on a building, threw the windows in, and that was that. Now it's much more, it's a project. It really is, to wrap a house properly. It's like wrapping a present in many ways. So we go through that. We also were never super cautious about leaving voids in framing. And now, you know, there's areas where Ray can never get to because he doesn't even know it's there. We spend time, we have stuff in the trucks all the time, so we can seal areas that, you know, unless you put an infrared gun on it, you probably know about. So, you know, we spend a lot of time with that we didn't used to. We also use engineered materials. Engineered lumber is very popular, and you know, it's a good use of resources, and it's also it's giving you a straighter house, and it's also a stiffer house by about 3 times normal KD stock. So you know, those things, composite materials have become popular. You know, on decks, you're not replacing them and maintaining them all the time. Plastics and PVCs, they're not for everything, but they're great in areas where you're going to protect the frame of your house and keep it from being damaged. So those things work really well. Pine isn't the lumber that it used to be. It's farm raised. It's raised like corn now, so it's raised to harvest. And you know, we're cautious of that because those things fail regularly, and we don't want things to fail. It's not. We have enough business without that. So we you know, we're trying to detail things properly so that they don't fail, and use plastics so that they, down low areas and areas, windowsills and things where they would protect the framing, especially, you know, areas where, you know, they're very vulnerable. So, you know, we have a lot of materials coming our way and a lot of new methods coming our way all the time, and it's just we try and pay attention to always keeping up with those. And then we refer to these people all the time for their input on a project. So that's pretty much it, I think. I think it's up to you guys to take it from here. Thank you.
I'm Pam DiViniti. I'm with Pella Windows and Doors. I'm an architectural consultant, actually, so I call on people like Heather on a regular basis and do educational seminars, lunch and learn presentations to the trade. But prior to that, I used to work in the showrooms, and I would interact with homeowners regularly and talk to them about their needs and what they were looking for. So let me talk a little bit about today offering some high-performance energy efficiency solutions when it comes to windows and doors. And this does have some Pella information in it because, quite frankly, that's what I know best. Hopefully I've left it as generic as possible so that you get the basic information that you're looking for tonight. Basically, when we talk about renewable sources, the goal of green design, as it states here, is to create high-performance buildings that incorporate design and construction practices that significantly reduce or eliminate negative impacts on buildings. And wood truly is the only renewable resource. Oftentimes you hear words like renewable and sustainable being used, and they're used sometimes incorrectly and interchangeably. Renewable, as I said, wood is the only material that is obviously a renewable resource for building materials such as windows and doors. But having said that, something else that you need to take into consideration is the amount of energy that's used to produce the materials that you're using in the building, in your buildings. Here, what it shows very significantly is wood, recycled aluminum, and fiberglass have the lowest impact on the environment. When you look at vinyl or you look at aluminum from raw bauxite being used, it's significantly, it's a significant deterrent in the environment. What we'd like to tell you here is approximately 27.5% of the total aluminum production comes from recycled aluminum in the industry across the board. Pella, however, can make the boast that we use 95% of our slash cladding, and 75% of our frame cladding is made with recycled material, something that we feel is very important. Usually when you start talking about materials that are being used, you look towards third-party validation, something like Energy Star. And Partner's been named as an Energy Star partner 3 years in a row. As of 2010, we've earned the Excellent Awards from the U.S. Department, the Environmental Protection Agency, and the Department of Energy. Basically what that means is we're responsible stewards of our environment. And again, 80% of the wood we use is third-party certified. We are now certified as an FSC certified provider. What that means is we're practicing and we're incorporating responsible forestry practices in the wood that we use in our product lines. And again, it's very important to make sure that the windows and doors that you're buying are manufactured by a company that takes it not only with the production that they're giving you, the material they're giving you, but also during the whole manufacturing process and how they handle that. That one didn't transfer so good, so unfortunately you don't have the figures. Basically, when we talk about glass, and this has been a moving target over the last year, the Energy Star guidelines have really changed within the last year and a half. And when you look at thermal performance in windows, now instead of single glazing, you have dual glazing, triple glazing, low E glazing. We'll talk a little bit about that in some of the subsequent slides. But basically, just so that you know, double pane windows compared to single pane windows basically cut your heat loss in half. That's significant. So for those of you that are living with windows that were produced prior to the 1980s, you're probably living with single pane windows that with true divided lights. And you're really probably getting a U factor, and this is how we measure it in the window industry, versus our values that you have with other building materials. U factors for single pane glass are about a 0.81. That's on a scale of 0 to 100. What Energy Star is now asking for is 0.30 or less on a U factor. What does that mean to you? That means that in order to have windows that now meet that new energy tax credit, which we'll talk about as well, that is going to be expiring at the end of this year, you need to have energy efficient products that pass those qualifications. The other thing we're going to talk about is solar heat gain coefficient. It's the amount of actual heat that enters the building through the glass. And any window that is manufactured and glazed in the factory should be carrying one of these stickers. This is from the National Fenestration Rating Council. And they're an independent board, they're a nonprofit organization that rates whole product performance. In this, you're going to see a few numbers that are extremely important. The U factor tells you how well the window insulates, and that U factor, as I mentioned, on a scale of 1 to 100, comes in, they are recommending 0.30 or less. For the solar heat gain coefficient, same thing. It tells you how effectively the window is at blocking that radiant heat from the sun. Both ultraviolet and also near infrared and far infrared as well. And so again, what they're asking is that windows conform to a standard of 0.30 or less. So again, those are some of the numbers that you're going to be seeing if you do purchase new windows. And for the new tax credit, you're supposed to retain these stickers with your tax documentation along with your proof of purchase, so that when you go to file your taxes for 2009 or 2010, you have documentation that you qualify.
Can I ask a question real quick?
Absolutely.
That's trying to say that solar, it's trying to block the solar heat?
Right, because what ends up happening is it's also for not only for heating but for cooling.
Right,
So
so you don't have cooling in your house and that's not a problem,
Well,
but
what
you
it-
actually want more heat.
True, but in the Northeast, you're not blocking out all of it. You still do gain quite a bit. But in the Northeast, you really want to cut down on a lot of it because if heat's going in, it's also coming out. And that's something else you have to be concerned with. There are other, for tax credits and for the Energy Star guidelines, the national government has mandated that for any kind of replacement window, this is what your building inspector is going to be looking for, a U factor of a 0.30 or less. So you do actually want to keep out some of that solar gain, yes.
And is there, like in many other laws, I forget the term, but some kind of kick out for something over 100 years old?
Grandfathering, basically. What they're actually saying now is, and again, this goes, it's city by city, town by town, as far as what your historical commissions are going to allow versus what the National Park Service and then again what the energy guidelines are. They usually clash to some extent. There's no doubt about it. There are, I will show you in a couple more slides coming up, there are windows with simulated divided light that give you the historical appearance of true divided light that have been accepted by various historical committees across the United States. I'm not saying necessarily, perhaps you're in Marblehead, perhaps not, it depends on exactly the location. But as far as when you change out windows, again, if it's in a historical district, that comes under a different criteria than just the general population.
Can I ask you a question also?
Yes, absolutely.
I built my house in 1960, it's all,
Yes.
they're all Anderson windows. I'd like to replace them, but I want to replace them from the rough opening. I want to take the outside frame, the 908 casing and all that off, etc. Can Pella do that?
Yes. Yes, you
It's
can.
not a replacement window, you'll have to match the same rough opening.
Right, and that's not a problem. Pella makes all their windows on a 1/4" increment for just that situation, and I do actually have a couple slides. We do two types of replacement windows, full tear-out, which would be a new construction window that you apply from the exterior of the home, and then a full pocket replacement window that can be installed from the interior of the home. We have a variety of different price points and different product lines that will service that. So yes, sir, we can do that for you.
But the price points don't represent the heat and
Yes, you're going to be able to achieve these types of U factors and solar heat gain coefficients and get the energy savings with the full tear-outs and at and again, various price points for different materials, depending on the window selection you're choosing, what kind of options and features you're interested in. So,
but they're all vinyl coated, right?
no, we do not. Our windows are actually aluminum clad versus vinyl. Aluminum is a more stable, more resilient material than vinyl. Vinyl is brittle in the winter, it's plastic. It breaks and cracks. And then also when it's very hot outside or there's exposure to extreme southern exposure, it can warp, it can sag, and it can chalk. So we do not do a vinyl clad window. We do an all vinyl window. We do not do a wood clad window with vinyl cladding. Does that answer that for you?
I know what you're saying. Just to mimic what Jack was saying, I was in business. I started off in the building wrecking business. The building wrecking business, in the old days, we used to tear down buildings and salvage everything. The bricks, etc., etc.
Yeah, yeah.
And I ended up in the plumbing business, the electrical business, the two-bagel hardware store, the lumber business, and I build houses. And I now go into Home Depot and Lowe's, and I am totally lost. I have no idea what they're selling. I used to sell vertical grain fur. There's no such thing anymore.
They don't even have it, and you don't see it anymore. That was the Cadillac in the day.
Was there a question in the back? I'm sorry.
Yeah, it's a full tear out. I have a 100-year-old home, and
Sure.
you know it is what it is. But with a full tear out, if the sills are not sealed properly, would a full tear out fix that, solve that problem?
Well, the full tear out, what your contractor is going to do is they're going to come in and assess the situation
Okay.
to see exactly what needs to be replaced. If you're doing a full tear out, it's a perfect opportunity to replace the sills as well, whether it's with historic sills, with a sub-sill, a historic sill, or just a sill nose. It's really going to depend on your project, and that's when you get some qualified contractor who can come in and give you that assessment. But exactly, and I actually, let me just advance this if I will, because what I'm going to talk about is when do you decide you're going to replace those windows or those doors? And usually the two top criteria are poor performance and high energy bills. Those are usually the two reasons. Others that come into play as well are things like fade damage. If you've got windows, solar heat gain coefficient, this comes back to where you were. With the lower solar heat gain coefficient, it also blocks harmful UV rays. UV doesn't only do damage with fading fabrics and wood surfaces and so forth, it also causes skin cancer. So it's been proven that with these type of low-E coatings that are put on windows, it drastically reduces some of those problems. Another reason is a lot of instances there's no adequate escape route. You don't pass egress. And when you start changing out openings and so forth, you need to bring things up into be code compliant. So that's another reason that people will often change out their windows. And then also sometimes it's just they're a hassle to clean and they don't operate well. A window's no good if it doesn't open, and it's supposed to. Natural ventilation is important in buildings. It keeps the building healthy. It's something that also for just creature comfort is something that's important. So let me show you the next slide, because I think we're almost there. We talked about air leaking, that's one of the reasons, but when you start putting in, I'm sorry for the colors, it's not translating well, but when you start using high-performance insulating glass technology, you eliminate a lot of the problems such as air leaking and also the fogging, which is basically what is called seal failure in the industry. If you've got double panes of glass that routinely fog up and you're getting moisture within, that's seal failure. And then also the old single pane windows that aren't energy efficient, they tax your heating system, they make it work harder, and they also require, if you do have air conditioning, for your air conditioner to work harder in the summertime. This is one of them. We'll go through the 4 series that I brought here today. There are 3 wood and wood-clad series. Architect series is offered either as an all-wood product or wood with aluminum clad on the outside, which basically is virtually maintenance-free. Historically accurate details with munting profiles and rails and stiles that are in proportion to windows that were made in the 17 and 1800s. As far as design flexibility, we can make them on the 1/4 inch for both replacement windows and new construction windows. And with new construction windows, as I said, you're taking off all your exterior trim, you're taking off your interior trim, and you're going right down to those studs. And you're putting in a brand new window, and then you're going to retrim it out. You're also going to, again, this is all going to be tied into the building envelope for water management purposes. And so that's one avenue. But another way to approach this is with what we call pocket replacements. And these are not sash kits. These are full windows that are manufactured in the factory. They're tested for water and air infiltration, and they carry one of those NFRC stickers certifying performance. They're fully assembled, and they easily go into the existing pocket. The only thing you need to take off is the interior parting stop on your windows. So things like your interior trim, your wallboard, any wallpaper, nothing is damaged. These go in very effectively and cost effectively from a labor standpoint because they can be put in within about an hour or less. They're not as intrusive to your lifestyle either as having the full tear-outs from the outside. Another option that is available is designer series with us. Now this is 3 panes of glass, and it was rated #1 for energy efficiency among top national brands in the industry for a wood-clad product. What it does also feature is a hinged interior panel that allows for blinds or shades to be put within the void. These blinds or shades stay dirt and dust free, so it's great for people with allergies. It also keeps the pets away from them, children, and because they're cordless, they're a lot safer. These can also be added later on into a project. So for new construction purposes, you can purchase the windows, and then when you're ready to decorate the house, you can actually put the blinds or shades in later and make those choices. With ProLine, and we're going again with the different types of price points here, ProLine is also a new construction window. It is not offered as a replacement window, so it is installed from the exterior of your home. It has very energy efficient. It has the most popular features and options that are available, but a very competitive price point. So again, for a wood-clad product, we have things that come in every price point. You're going to hear a lot about fiberglass, and this is a very green material. Fiberglass composite is what we call pultruded. It's a thermoset process. It's not reversible. But having said that, with the thermoset process, fiberglass is made out of glass. It's silica, it's sand, so it's sustainable. It's a naturally occurring material. And because of that, also fiberglass, you can think of things like boats and shower stalls, bridges that are made out of this. It's also extremely strong and durable. Fiberglass is 9 times stronger than vinyl. It's 3 times stronger than aluminum. It's got great durability, scratch and dent resistancy. It is extremely thermally efficient. It has the thermal efficiency of wood, so you can achieve that 0.30 U factor or less. It has very low maintenance. So it comes directly from the factory, pre-finished, ready to install. As I mentioned, it's sustainable. It's a much greener product than vinyl, which is petroleum, or aluminum, which is bauxite, and it is competitively priced. It's got a very nice low price point. So again, one of the best bangs for your buck in the industry, and I think you're going to see a lot more windows and doors. We offer a full line of windows and fiberglass entry doors. And our fiberglass entry doors have they're 5 times better insulating value than wood. So just again, they do come wood grained or paint grained. So again, you have a lot of flexibility from a design standpoint. Now, as far as windows or doors or any other building material, it's great on the day that it's put in, but what about the service? Who's going to be there to service it? And we're locally owned and operated. We operate out of payroll, we do have local ownership that is very hands-on. And this is our warehouse and where our service techs work out of. With every Pella product, we offer 2 years worth of free service. That's great for the contractor because they don't have costly callbacks for minor problems. It's great for the homeowner because they don't have the hassle of trying to find somebody to come in and fix little issues. We also have a full range of parts available many years down the road. When I was in the showrooms, we used to be able to provide parts for windows that were 20, 30, 40 years old on a regular basis. So it's important. And we were ranked #1 in customer satisfaction by Pella Corp for 2 years in a row out of all of the distributorships across the country, which are 80 distributorships. So we're pretty proud of the fact that we're putting our customers first and making sure that you're very satisfied. Thank you. Is there any questions? I'm sorry, I tried to go through that as quickly as possible. Yes.
Do the U-value requirements change from climate zone to climate zone?
What they do is, that's a good question, yes they do. Here in the Northeast, it's a 0.30 or less for the U factor. In the southern states, there are different requirements, same with the Southwest and so forth. Very good point, yes. Perfect. This has also been a big change. Since 2009 is when the federal government got involved with this and started making these mandates, and it has been a moving target. So the glass companies, the glazing companies, are the ones that have had to retool and come up with the better performing product lines. So, and then we followed suit once those product lines were available. Does anybody have any other questions?
Are all the windows insulated the same?
As far as
The argon gas?
Thank you. With argon gas, and that's a good question, for Pella windows we use argon gas as an inner gas. When you have 2 panes of glass, there is an air space in between. And you can still, for some historical applications, have that void just be void. You just have clear insulated glass without argon. And some historical boards will ask for that. Pella uses an argon gas. Other manufacturers use other inner gases, such as you may have heard of krypton. That's another one that you hear. But argon comes at the best price point for those type of windows. And in the factory, what is done is those glass packs, those 2 pieces of glass are sealed together. There is inside of it, there are low-E coatings that are applied in the factory. And those low-E coatings, depending on how many coatings are, will determine also how energy efficient the window is. So some have 2, some have 3. Also, the argon gas also increases that energy efficiency. So as a combination, once that's all sealed in the glass pack, it's then inserted into the frame of the window. So yes. Yes.
What is it about argon gas that historical commissions might have an issue with?
It's more of a tinting situation, and that's basically what you see. When I say historic commissions, I'm talking of like the National Park Service. Oftentimes for buildings that were built prior to 1934 that are going for federal tax credit with the National Park Service, that's when you get into more of that, not so much with local residential historic boards.
So the gas is not clear?
It's clear, it's just that it does give some reflectiveness to it at times, and also with that low-E coating. So it just depends on the historic board, but generally speaking, what I'm discussing is more for commercial applications. We see it more with those, not so much with residential. Usually that is not the issue. Yes?
What has changed to create the better insulation so that you don't have the fogging and breakdown of the seals?
Well, again, the seals, when we're talking about a seal, you're talking about inside, when it's factory glazed and factory sealed, again, that is all done with, in the factory with different types of resins and so forth and sealants. That's basically what it's done, but different manufacturers come at that differently. So for instance, with us, we do a 20-year warranty on the glass seal. It's not prorated, which means you don't use it up. If it fails after 19 years, we don't say, well, you've used up 19 years of your warranty, you only get a year's worth left. And it's fully transferable. Not all manufacturers go to it that way. But what basically has changed over the years is just better technology. That's really what better assembly practices. That's really what it comes down to ensure that. You're welcome. Any other questions? I should probably turn this over then and let it be, since I've taken up way too much of your time. I unfortunately have to leave. I have another engagement. I have left on the back table some information on the federal tax credit for anyone who is interested in replacing their windows, just so that you understand what the guidelines are by the federal government, this does expire at the end of the year. And so I wanted to make sure that any of you that were thinking in terms of this had this information available. In addition, I've left some business cards on the back. If there are any other specific questions that come to mind after I've left, my email address is on there. Please, by all means, just shoot me an email, let me know you were here tonight, and I'll be happy to either answer your questions or point you in the right direction so that you can get the information you need. Thank you very much. Thank you.
My name is Ray March. March & Martin was established here in Marblehead in 1976 as an insulation company. We insulate new and existing homes. As you might expect, building technology has changed quite a bit over the last 34 years. We've transitioned from traditional insulation materials, fiberglass, cellulose, and rock wool, with some attention to weather stripping, to insulation materials that both insulate and air seal at the same time. Our diagnostic tools now include blower doors and infrared cameras. Doors and windows, as we just heard, have become much tighter, and our glazing materials much more sophisticated. The desired results were greater energy efficiency, increased comfort, and greater control over our interior environments. In the 1970s, we had an energy crisis that drew our attention to the cost of heating and cooling our buildings. At that time, the approach was simple: increase the insulation R values, and that should increase our efficiencies. We also increased our attic ventilation standards to address moisture management issues. An interesting thing happened. There was very little change in our energy consumption. Increasing the R value was really not the answer. There are three major types of energy transfer: conduction, convection, and radiation. Conduction is movement across the solid or material-to-material contact. An example being a pot with a metal handle on a stove. Convection refers to energy transfer by air movement, drafts, air infiltration, things like that. Radiation is the transfer of heat energy through empty space by electromagnetic waves. Building scientists were beginning to realize within the three types of energy transfer that convection or air change was a major contributor to heat loss and heat gain in our homes. With approximately 93% of conductive heat loss being stopped by an R13 insulation material, additional R value provided very little added benefit. Building scientists were also realizing that different climate zones require different standards for R values, vapor retarders, and air leakage control. We're in climate zone 5, which is considered a cold climate zone. However, in New England, we have significant seasonal shifts in both temperature and humidity to consider. The focus on air leakage controls provided a range of other positive benefits as well. It helped control moisture transport, condensation, helped control mold and mildew formation. It added structural integrity and durability to our buildings, improved air quality, and improved the health of both the building and the building occupants. Controlled drafts and energy conservation improved. Up to 50% of energy can be lost through air leakage. As our buildings get tighter and tighter, energy conservation improves. However, concerns about health and indoor air quality go up. Thus, our mechanical systems become more and more important in regulating our interior environments. We've come to realize our homes are systems that need to be designed in ways to work together and perform properly. With the advent of spray foam technology, our building envelopes can both be air sealed and insulated at the same time. Given the often complex designs and framing details, the custom fit of foam is perfect for today's structures. With foam technology, insulation can now follow the roof line of a building without the need for ventilation. In the past, the top floor of a building was a pretty good pressure plane. Perhaps one light fixture in the middle of the room with a switch when you entered. Today it's a very different story. That upper story, that upper ceiling is more like Swiss cheese. The standard thermal bypasses have been chimneys, pipe and wire penetrations, partitions and wall framing, walk-up stairwells. While we also have today recessed lights, bath fans, pull-down stairs, attic hatches, speakers, and often duct drops with air handlers above in the attic. By insulating the roof line, all of these penetrations become neutral and fall within the conditioned envelope. This method also helps prevent other building problems that we're all too familiar with, such as ice dams, frozen pipes, drafts, recessed lights, and general heat loss through the envelope. Insulation is only one component of our building systems, but it is a very, very important one. Thank you. That's it. Any questions? Yeah.
I have an elegant solution for insulation,
Okay.
but nobody will listen to me.
All right.
I would like to be able to find an insulating paint, since I have to paint my house. And I'd like to have a paint that has some insulating qualities to it. Does it exist?
Well, there is a paint that is being tested, and it's certainly not on the market that I know of, but it's more for photovoltaic and very low-level collection of electricity. I suspect there's an insulating paint somewhere, but I'm not aware of it. It'd be nice to do two things all at once.
Exactly.
My name's Steve Hergott. I work for Uptack Plumbing, Heating, and AC up in Haverhill. We do come down this far. I know you're going to have lots of questions. I'm going to stay as long as you might want to ask later on. My goal tonight is to just introduce you to maybe some products you haven't heard of yet. Tell you maybe a little bit more about some you do know. Uptack's been around about 28 years. And before that, the owner worked for his father for 25 years before that, so he's been around a long time. I've been in this industry since 1980. I have 2 engineering degrees. My mother and father are from Germany, so I have this German engineer mindset, which means I can talk too much. You know, Uptack, we didn't know we were green. A good 10, 15 years ago, we did some geothermal systems up in Haverhill. It was just the thing to do then. It wasn't a green thing to do, but we've got 15 years of geothermal experience. But geothermal is kind of glamorous and not for everyone. You know, we think a good gas condensing modulating boiler is a great place to start. Technically, maybe not a green product, but again, it uses clean natural gas and it's very efficient and it's a great way to lower your energy bills. 95% of the heating equipment we probably put in as a company is some kind of gas condensing boiler. This brochure, this slide talks about one, which is Wiesmann, which you probably have all heard. I got to go, it's German made, I got to go to the German factory for Wiesmann a couple of years ago, and there's no better boiler made probably in the whole world than a Wiesmann boiler. I am going to mention some product names. It doesn't mean that that's the only good boiler manufacturer by any means, but Wiesmann's got a great reputation. So once you produce energy and produce heat or BTUs in your house, what's the best way to get that heat into your house? And there's many great ways. Right now, we focus on doing that with the lowest temperature heated water possible. So the lower, the better in our mind, the more efficient. So this shows a picture of radiant floor heat. We can often heat a house with, say, 100 degree to 120 degree water flowing through pipes in the floor and heat your house. So that's a great green technology and a great way to heat. And again, it was mentioned earlier, it's not for all areas of the house, but boy, it's great for bathrooms and kitchens and any place you might put tile down. It's great to put radiant floor under that. Next up the ladder, I'd say, in choices for heat for your home would be a nice panel radiator. Panel radiators go by such names as Runtal. Runtal happens to be down the road from us in Haverhill. So Runtal radiators are a true radiator. We could design these to heat your house with 120 degree water going through the Runtals. That means the Runtals would get a little larger, but we can certainly do it. If you go to Europe, how many people have been to Europe? In Europe, I bet you've seen radiators everywhere, right? I mean, Europe is just filled with radiators, all different types. And there's a typical, I call them European panel radiators, made by many companies here that we can buy. Vidaris happens to be one, so not as glamorous a look as a Runtal, but a great way to heat a house too. Now I'm going to transition a little bit to hot water. So the next biggest energy user in your home next to your heating system, which might be a boiler or a furnace, would be your water heater. So now I have to ask the question, if I say on-demand or tankless water heater, how many people here think they know what I'm talking about? These guys have done an unbelievable job of marketing on-demand. I mean, you hear them on the radio, I think you probably see them on TV, they've been on all kinds of radio stations. So this happens to talk a little bit about a Rinnai. I know you can't read that, okay, but Rinnai is one manufacturer of a on-demand tankless water heater. I put one in my house about 5 years ago because my wife and teenage daughter kept saying, how come we're in the business and we run out of hot water? What's up with that? So we put a Rinnai in and literally this guy could run forever. They could stay in the shower 24 hours a day and be happy. This guy would keep up with the demand. There's no stored water. There's no losses. If you're not drawing hot water, this thing's off. It's not doing anything. But as soon as you turn hot water on, and this thing senses flow, and then it fires up and produces hot water. They're not inexpensive by any means. They're a pretty pricey product to put in, but and we don't know how long they're going to last. When you open one of these up, it reminds me of the first time I got a foreign car and opened the hood and saw all this stuff under the hood. That's kind of what this is when you take the cover off it. But luckily, they don't break and they don't need service. So that's called an on-demand water heater. I'm not going to talk much about solar, but I'll just say from being a plumber, there's nothing simpler than putting a couple of solar panels on your roof and producing hot water using solar technology. It's simple. A couple of collectors, a pump, some pipes, and a storage tank, and a very simple controller. It's easy. Been around forever. Thank goodness it's getting popular again. I mean, I got into this industry in the early 80s because of this. Now here's probably something new that you may not have ever seen or heard about. Daikin's the brand, but many companies in the world make this product. We call it, the generic name we give to it is variable refrigerant flow products. Variable refrigerant flow. So there's a single outdoor unit, we'll call it a heat, so it can heat and cool your house. The piping between the outdoor unit and the indoor unit is refrigeration pipe, so there's refrigerant in that. And we combine any, see those 5 different products there. There's wall hung product, you've probably seen, Sanyo, Mitsubishi, those kind of products. And then there's a ceiling cassette product, and there's a floor mounted product, and then there's a couple of ductable products that we can hide in the ceiling and above closets. So here's a great way, in my mind, to do some challenging homes and do heating and cooling without fossil fuel or in addition to fossil fuel. Plenty of times we put a gas boiler in and these kind of products. So variable refrigerant flow. I think this is part of the future. Architects and engineers absolutely love these products right now, and many, many buildings are being spec'd with them. And I love this business because we have to heat, we have to cool, then we make the house too tight and we've got to ventilate it. You know, and then we add humidity in the winter, and then we got to take it out in the summer. It just goes on and on. So here's a product called an HRV, sometimes called an ERV, heat recovery ventilator or energy recovery ventilator. So when a house is too tight and it needs to breathe, one of these products can go in an attic or a basement. And what you see there, if you can follow it, is fresh air, blue coming in through the roof vent into a product, the HRV. And then that fresh air gets distributed to the house. And then we take stale, smelly, moist air out of the house, often out of the bathrooms and the kitchen. And we duct that up to the unit, and those air streams pass each other. So that warm, moist air passes that cold, fresh air coming in, gives up its heat to that airstream, and then that fresh air comes into the house to ventilate. Most good HRVs come out of Canada. Canada pretty much almost legislates that these must go in tight homes. America's getting there. Now in Massachusetts, if you were to finish your basement and you didn't have enough windows, the code is you must put something in to ventilate that space. That's the law in Massachusetts. And then when I was in Germany a year and a half ago, many, many, many companies, I went to the biggest trade show in the world for heating, air conditioning, and plumbing. And I saw this concept in numerous places, and it got me very, very excited. And now it's finally come to America with now 2 manufacturers, and more will be coming. So what you see here in this schematic is what I'll call the outdoor unit is an air-to-water heat pump. Air-to-water. We're going to extract heat from the air and make hot water, about 120 to 130 degrees Fahrenheit out of the air. So use the air to make hot water. But the neat thing about this picture is again, the house as a system. So in this picture, somewhere in there is a gas boiler, and we have an air-to-water heat pump, and we have a couple of solar panels on the wall, and you see some radiant floor heat, and you see a fan unit. So we can heat and cool all different kinds of radiation and things, and one controller somewhere there, which I think should be in your living room or in your kitchen on the wall, which will show you graphically what's going on at the present moment. Like the sun's out, it's fairly warm, we can heat with the sun today, the gas boiler's off, the heat pump's off, we're heating with the solar because it makes the most sense. Sun goes in, temperature drops, let's say it goes all the way down to 0, the air source heat pump isn't going to make any sense anymore, so that cuts out and the gas boiler comes on. And that control is going to know what's going on all the time and tell all those different things what to do. And you'll be able to go to this touch screen and then see what's happening. So I'm there at one of these booths in Germany, and I'm really excited. He asked me some questions where I'm from. I said, well, I'm from Massachusetts. I say, around Boston. He goes, Harvard, this German guy. Harvard, MIT, those are your customers? Yeah, those are my customers. Yeah, the Hydro box is it's the Daikin's name. That happens to be the manufacturer for the interchange between that outdoor heat pump and making the hot water and storing it. So it's like a heat transfer device, and we gave it that name. If there's one fun product I want to tell you about, it would be this one. This is called an ecobee thermostat. And this slide doesn't do its justice, but I'll tell you about it. I just put this in my house about a month ago. My wife absolutely loves it, which is amazing, because most of the stuff I put in the house she doesn't get that excited about. This is it's wireless. If you have wireless in your house, it automatically senses the wireless, what's in your house. It's touch screen. I don't have an iPhone, but if you have an iPhone or any of those, it's just like that. You go up to this thing and you can just slide your finger around and move the things around and move the temperature sensor, so it's very, very easy to program. But because it's wireless, you know what I'm going to say next. You can access it from your phone, from your laptop, and that screen pops right up, so you can check on your house. It has all kinds of graphing things. You could change it, reprogram it. You could be away and coming home and turn the heat on. There's a zillion things you can do. And then there's a neat button on the lower left side. It says weather. Again, because it's on the internet, you've told it where it is on the planet. It knows what the weather is there, and if you push that button, it gives you the 5-day forecast right on the screen. It's a really neat echo bead. It sounds green, right? It sounds like a green product. I really wanted to end my talk with that.
I've got a question on the Renai tankless. How big is it compared to the old water heaters, and where does it go? Does it have to go in the basement, or can you put it up in the master bathroom?
Because of the way it wants to vent, the easiest venting is to hang it on an exterior wall and the vent and intake them right off the top and right out. That's the install we look for, because you bring up a great point. The basement's often not a great place to put it, because I can rarely do that up and out. So upstairs is great. In Europe, that would go, in the laundry room. That's an exterior wall. So finding a place for that could be tricky. Physically, they're about that tall, about that wide, about that deep. And they make a little sound when they come on and off. That could be an issue. They can hear it ramping on and off. But they come different sizes. There's residential sizes, commercial sizes. Great product for like a car wash. We've done a couple of car washes where you just put maybe 4 or 6 of them in a row. Well, the other neat thing about the on-demand is it comes with an electronic control, so you can punch what temperature you want. So in my house, when I take a shower, I punch 104. Remember, German engineer, 104. Don't have to mix cold. I turn the hot on, I don't have to mix cold. 104 is just right for my body, so I turn it on. And what it does, it senses, if it's 3 gallons of milling going through there, it senses the flow and turns the gas valve up to produce 104 degree Fahrenheit, 3 gallons a minute with this much input.
Will it run on propane?
Propane or natural, yeah.
How about electric?
Right, that's not an electric product, that's a gas. But there are tankless electric water heaters, like on demand that you can put under kitchen sinks and bath sinks. There are electric.
Solar. We do solar installations for homes and businesses. I'm just going to give you a quick rundown on our company and just how solar works and the advantages of doing it, financial, environmental, and the steps you need to take if you're interested in going forward with the solar project. Just to begin, Sunlight Solar, we're one of the older solar companies out there. We've been around for about 23 years now, but we're fairly new to Massachusetts. We came up here from our Connecticut office a year and a half ago now. Since then, we've done about 50 or 60 installations, mostly residential, a few commercial. That's us. Just a quick rundown on how solar works. I'm going to keep this pretty light on the technical side. I just don't want to bore half you to death, but basically how it works is you have photovoltaic or solar electric panels like this one here. They go up on the roof on the south side of your home and produce a DC current. The DC current runs down into an inverter, which is about that big, runs down in your basement, converts from DC to AC. AC runs into your home electric panel and into your meter, and your meter will spin backwards. From there, you're going to be powering the house with this AC current, and also connected to the grid as well, so you don't need to do battery backup systems, which about 10 years ago were a lot more popular. Right now, they've really fallen out of favor because they're just very expensive. They're an extra $10,000 usually to the whole project for really no gain. You can use the existing electric grid as your backup system. So your solar system will power anywhere between 50 and 80% of your home electric needs, and the remaining 50 to 20% will come from the grid. And so you'll only be paying that remainder from the current existing utility. There's also, as Steve was talking about, solar hot water, another type of solar. That's as he was saying, to heat up a hot water tank to use for typically just domestic uses, showers, dishes, laundry, that kind of thing. There are applications for heating your house, but they tend to be a little more expensive than to make common. So we don't do a whole lot, but there are options for that. I'm sure the reason a lot of you are here are interested in reducing your carbon footprint. Solar is a great way to go. It has a lot to do to offset your carbon footprint. It's the equivalent for a 5 kilowatt system, which is about average for Massachusetts. It's equivalent to planting about 30 acres of trees in terms of carbon. We're not driving 237,000 miles in your car. So it's a huge offset to your carbon use. As we mentioned, there's a whole lot of ways to go solar, or to reduce your electric use. And that's usually where you want to start. You know, it's important to go solar, but that's usually not the only avenue you want to approach. You want to go up from both ends. Reducing your electric use will make the system pay itself off a lot faster. So as these folks were mentioning, there's a whole bunch of options for doing that. There's also some simple things you can do, like using power strips. Power strips, just simple power strips that go into your outlet. You plug everything, all your appliances into that, and when you're not using it, you shut that power strip off. And what that will do is stop what's called your phantom load. A lot of items that are on or off will still be using about 10 to 20% of electricity they'd be using if they were still on, running at full blast. Things like computer chargers and phone chargers and TVs and even some lamps and appliances like that will have this phantom load. So if you can shut that load off, you can save 10 to 20% on your electric bill from that alone. Passive solar is another option. Just as simple as just opening the blinds during the day if you're trying to heat the house, and closing them if you're trying to keep it cool in the summer. Free energy audit is a great way to start. They even give you a couple free light bulbs, which is nice. It's a free service. You go to masssave.com, or you call that number right there. They'll come out to your house and they'll give you a pretty basic walkthrough. It's not too robust, but it'll give you some good tips on how to start reducing your carbon out or your electric use, and get those light bulbs. Solar dryer. It's a nice simple one. What you do is you take string and you tie it from your porch. You hang your clothes and just dry it that way. It saves you a lot. And then solar thermal, as Steve was mentioning earlier, is another option. The economic reasons are huge in solar. It's the best time we've seen in the state for going with solar electricity. Right now there's 3 programs in Massachusetts that all combine to help reduce the payback of the system, make it very affordable for just about everybody. Also, it will help you control your electric costs. As we see, there's typically about 5 to 7% increase in electric rates each year. This is a great way to hedge yourself against those increasing rates, because you'll be locked into a constant electric rate from getting electricity from the sun. Typically, cover about 50 to 80% is average. Some homes would cover 100%, some 120, 130%, depends on your use, depends on your roof. But usually you want to shoot for about 80%. And I'll explain why in a minute. It also adds quite a bit to the value of your home. According to the U.S. Department of Housing and a study from the EPA, for every dollar you save in electricity, it adds about $20 to the value of your home. So the average system, this adds about $20,000 to the value of your home, and it's exempt from increasing your property taxes. It's one of the few one of the few improvements you can do to your home that won't make your property taxes go up. That's a state law, makes it completely exempt, and there's a couple websites that can give you backing that up if you're interested. Are sold off to companies like NSTAR or National Grid or large manufacturing companies that have high carbon outputs that need to buy these credits. And so they'd be buying them from you at about $285 for every megawatt hour that you produce. And what that works out to be on the average system is about $2,000 a year minimum from producing green energy. So every year, for at least the next 8 years, you'll be getting $2,000 for this system. They're actually auctioned off, so they can be quite a bit higher. That's the base price, the $285. Right now, in August, the last auction they had, they were going for about $500, so almost twice that value. But the minimum quote is about $2,000 a year. Quickly how that works. So you'll have a monitoring system in your basement that will calculate what you produced through your solar energy, and that will be reported automatically through a wireless system off to a company that will aggregate these credits from various people like yourselves that have solar on your roof. They auction them off to the companies like NSTAR or National Grid. They then buy them from you, and you get a check every quarter. And so yearly that amount is roughly around, on a 5 kilowatt system, about $2,000.
Can I ask you a question?
Of course.
So you don't have to do any paperwork on that?
Just there's one sheet to sign up for it. We help you with that, and then after that you're good. And then it's all done automatically through that monitoring system, so there's no constant work on your end. You don't need a monitoring system if you want to report it yourself. If you have the time to do that, that'll save you about $1,000 on the whole project, because that's what those monitors go for. But most people tend to want to have it done automatically. But we give you the option, of course. But yeah, there's no constant paperwork. There's nothing you really have to, really be on the ball with. Do you have a question?
What's the expected life of a solar panel?
Sure,
Or PV
sure.
panel?
Yeah, they're warranted for 25 years, any of the panels that we use. So that says that after 25 years, they'll be doing at least 80% of what they did when they were first installed. They're expected to last more like 45 years. But, this technology hasn't really been around that long, so it's an estimate. But that's typical. The average panel goes down about 0.5% in production a year, 0.5 to 0.8, depending on which type of panel you go with. But after about 45 years, they'll still be doing around half of what they were doing initially. So it's very, very slow degradation, so a long life expectancy.
There's 25-year material warranty, not
Yes.
warranty,
Yep.
labor material.
That's the power warranty. So that's based on just production. So as long as your production is doing at least 80%, you're good. If it's doing less than that, you get a brand new system, which is pretty nice. So you just go with PV panels, solar electric panels, 25 years. With solar hot water, about 10. Depends on which you go with. Schuko, German company, or Velux, it's all 10 years. If you have a southern exposure with very low shade, then electric is the way to go. The PV system is the way to go by a long shot because the payback is much higher, but the initial cost is much higher too. So if you're looking to just have solar, and you want to do something that's simple and it's green and it's less expensive, then solar hot water is great too. It's less affected by your shade and by the orientation of the house. So if you don't have a perfect site for PV, solar hot water is a good option. But it depends what you're looking for. The payback on solar hot or on electric is much bigger in the long run. So this is just a quick case study. This is a home down at Cape. Small system. It's 14 panels. This is Robinsons. They are actually the first system I sold when I come up here. It's in Wareham. So these are sun power panels, just like this one down here. This is a smaller demo panel, but it's the same technology. So this is how it works. These numbers are a little bit dated. Actually, cost has come down a little bit since I first put this up. But it's the initial system cost is about $26,000. You're going to get a rebate that's going to come right off the top, brings it down to about $19,000, and then your tax credit will be used to reduce your taxes in the following year. So you write that off of your taxes after that, makes your final cost $12,000, and then you're going to be saving almost $800 a year on your electric bill, and also making a minimum of this $1,100 off your SREC income. That's the minimum. Right now it's closer to double that, but let's just say we quote the minimum. That makes the payback about 6 years, or roughly a 17% return on your investment. So a lot shorter than it used to be. Last year, actually in 2009, the payback was on average between 15 and 12 years at best. So we've come down about half since then, which is definitely making it a lot easier for us. I'm sorry?
Why did it come down?
Well, it's actually the rebate program, the SREC program was new. We copied that from New Jersey. We didn't have that before. We just had a rebate that came right off the top. But after that, it's just your electric savings that helped recoup the cost. So now with this, you're actually making more money off your SREC income than you are from your electric savings, and that shortens the payback down tremendously. Pretty aesthetically pleasing. It happened with this house. It actually worked out perfectly where it just fits evenly with the roof. But it's a simple rectangle typically on most homes. We can't work around vent pipes or things like that, or we can't reroute those pipes and put the panels evenly on your roof. But it tends to be fairly inintrusive with your system, with your house. So it doesn't really hurt the look and adds a lot to the value. What kind of objections do historical societies have with this kind of technology? It's usually not a whole lot because it's entirely reversible. Say in 15, 20 years you want to take these panels off and go back to the initial look of the house. That's easily done. There's just a couple roof penetrations. They're easily just flashed over and sealed, and that's it. And then you're back to where you were 20 years ago. But it's usually pretty easily embraced by a lot of communities as it's a green technology. Most people aren't going to fight you on that. They understand the need for green, sustainable energy, and it's usually that alone will kind of sell it for us. Various types of panels. These are evergreen. They're local. They are the greenest panel on the market, which means in terms of the carbon output from making them, they'll recoup that carbon output in about 2 years, where most panels take about 4. So it's actually a very green product. It's made in Fort Devens. It's a little bit different look. It has polycrystalline, so you can see there's a couple different, if you can make that out, there's a couple different colors on there, as opposed to just an even color like the one here. Still, it's above average production. It's a great technology, and it's a little cheaper than the sun power panels. The maintenance is very low, if any. The rain's going to take care of any cleaning needs. If your roof is as reasonably pitched at all, 25 degrees or up, then the snow's going to slide off within, about a day of a heavy snowstorm. These panels actually, they're tempered glass on the outside, so they stay pretty smooth. And from the black panel and actually the resistance of electricity running through them, they stay a little bit warm. So in the winter, they're actually going to make a thin film of water. That snow's going to sheet off pretty quickly. Really, there's no internal maintenance. The inverter's warranted for 10 years. If you want to do any maintenance at all, you can brush out that fan every year or so, but that's just about it. There's really no moving parts up on the roof. So really not a whole lot.
Are they incorporating that technology into roof shingles and so forth?
Yeah, roof shingles, we don't do a whole lot of them. We have done them in the past, but the thing is their production is much lower. It's about a third of the efficiency of panels. So they look nice and they're good technology, but they haven't caught up to panels yet. So in terms of recouping your money fast and making a much better investment, we tend to go with panels.
How do those work?
The shingles, they're actually just mini panels. Typically they're done run in series and they're actually all run down into an inverter. Some of them, the newer ones, have little micro inverters in the back. That's what converts from DC to AC. But typically they're all just run together into an inverter, just like regular panels.
They don't have a glass panel on it.
I'm sorry?
They don't have a glass panel on it, right?
Some of them do have a tempered glass sheet on them. The newer ones, they have just the wafer protecting it in a plastic sheet. But it depends on what you go with. They're decent. They haven't caught up yet, so we don't really do a whole lot of them yet. You need a lot more roof space to get the same kind of production. The cost is a lot more too. It's just a little more labor intensive to install and that kind of thing. But they're getting there.
What about roof penetrations when you put this on?
Sure. Yeah, that's a good question. The roof penetrations, they're just L feet that sit on top of the roof. They're going to be lagged directly into the rafters. It's all sealed and flashed around there, and then a railing system will go up on top of those little metal footings, and the panels sit on top of that. It's good for 120-mile sustained winds or 170-mile gusts. We have a 10-year labor warranty, which is the highest in the industry, so any issues with leaks or anything like that is all covered. We'd fix the leak and the damage within 10 years of the installation. We have actually a perfect track record in Massachusetts, not a single leak yet, so it's pretty good. Are installing that next week on the Tip O'Neill building. It's across from the garden. It's a combined system. It's a hybrid system, so that means it does both solar electricity and solar hot water. So it's pretty cool. How it works is you have the panel, and then on the back of that panel, you have a metal sheet, and in between that sandwiched between that is a piping with glycol solution, which is a non-toxic form of antifreeze. And how that works is it gets heated up by the ambient temperature and from the heat coming off those panels. Heats up that glycol solution, runs down into a tank, and heats up the water tank from there. So you don't even see it. It fits right on the back of the panels. You have no idea it was there, but it actually produces quite a bit of hot water for you. So it costs actually about the same as a regular solar hot water system. So, which is all said and done after your tax credits, usually around $5,000 or so, depending. But it's good for it heats an 80-gallon tank or 120-gallon tank, depending on what you go with.
Is it true that they say that incorporating a thermal solar with the PV solar, that the PV actually produces better power because it's being cooled?
Yes, that's very true. So how that works is heat is a degrader of electricity. So if you have a system it's electric and it's running hot, it's not going to be as efficient. What the combined hybrid system does is it actually pulls that heat away from the surface of those panels and draws it into that glycol solution and then down in the tank. It makes it about anywhere between 3 and 10% better, depending on a few factors, if it's monocrystalline or polycrystalline or climate issues, things like that. But it actually makes it produce a little bit better. So it'll speed up the return on your investment by a little bit. Sure.
So it's a hybrid panel they make.
Yeah, it's actually it's the hybrid system will work with just about any panel. So you could get any type of regular PV panel like this one here, and then the hybrid system will just sit on the back of that. So they do work together. They are essentially one unit, but they fit together with any model.
Do they make panels that are combined the two technologies in one panel?
Yeah, they do. We don't sell them just because it leaves the option open for if you want one or both, and doesn't really change the price. But yeah, it works just as efficiently to have it done as a separate system that combines seamlessly. But yeah, they do make
Together or whatever.
Yeah, pretty much. They just clip together, and that's it. So pretty simple stuff.
Is there any limit or restriction on how much electricity you can sell back to the grid?
Not anymore. There was last year. Not anymore. You can produce as much above your production as you want. The trick with that, though, the reason we don't really shoot for a whole lot more than 100% of your use is because when they buy that energy back, say you produce 130% of your electric needs. So that extra 30% that you're selling back to the grid, you're going to get paid for it, but you get paid at the generation rate, which is the cost minus the transmission charge. So it's between 2/3 and half of what you're paying them. So if you produce all this extra energy and you start selling it back, it slows down the return on your investment. It's totally viable, and there's no law saying you can't do that, but just it doesn't always make economic sense. You know, a lot of people they have a big open farm field and they want to put, you know, they want to build a power producer and produce all this stuff, but they're actually going to be buying back at less than they're producing. So we don't do it too much, but it is possible, and there's no restrictions. If you are interested in having a site survey, we offer a free service where we actually come out to the house and take a look and see if first off, it's a suitable site for solar, and if so, how many panels we can fit and what that would cost you. Generally, what we're looking for is a house that's roughly facing south and doesn't have too many trees around it. Steeper the roof, the better, typically, but we're flexible on that. Generally, what we're looking for is a house that's roughly facing south and doesn't have too many trees around it. Steeper the roof, the better, typically, but we're flexible on that.
I'm an architectural color designer. My name is Kimberly Germain. My work is to shape architecture using light. A lot of people think that what I do is pick wall colors or paint colors, but I actually choose the colors for every surface because light is reflected off of all surfaces. So I'll be just talking about interior atmosphere, or the way I would shape and work with light interior for residences, but I do this work to shape architecture on the exterior as well, to make it suitable for the landscape and for any requirements of the portions of the building. I'd like to talk a little bit first about the paint use, or the green use of paint, because I know that that's a concern of a lot of people right now. When you seal a house, or when you limit the airflow of a house to make it so that it's energy efficient, you can have problems with outgassing of materials, having that outgassing trapped and fouling your environment. And companies that produce paints have spent a lot of time engineering paints that limit outgassing. As paints have been developed, that's been a major concern, particularly for the interior of the house. Also, limiting the toxicity of the paint that gets scraped and then put into the environment is another important factor to think about if you're considering your environment and considering the interior environment that you live in. All of the paints that are on the market currently are moving to limiting an element called VOC, or volatile organic compounds. Those elements are toxic. They are part of the system, or they get outgassed into the environment. So you want to limit VOCs as much as possible. And the paints that do limit VOCs have become much more efficient and long-lasting than they used to be. About 10 years ago, I was working on a school project that it was a Montessori school. They wanted to use a low VOC paint. They picked the one on the market that was the greenest paint, and within 3 months of painting the building, they had to repaint the interior again because the paint failed. It chopped and it dinged really easily. So just up stairways, any place where the kids congregated was, the paint was easily damaged. But in the last 10 years, the quality of low VOC paints has come a long way. So right now, people who are considering the products that they're using in their home to make it more green, to make the environment more suitable for habitation, are using low VOC paints. There are some paints that are called no VOC paints. Some of those are advertised as having no volatile organic compounds, but when you put the colorant in the paint, the colorant has volatile organic compounds. So that can change what you think you've just purchased. So you need to be careful of what you're purchasing, whether you think it has no VOCs or whether you're happy with a low VOC product that will work. One of the ways I judge paint use is how long it's going to last and how much of it is going to get into the environment. And there are a couple of different ways that it can get into the environment. A lot of times we get a paint use that is extreme because people sample paint a lot to pick the right color. So they end up buying many quarts or even sometimes many gallons to get the right choice of color. That then goes, the paint that you don't want goes into the landfill. Also, paint that doesn't work, that fails over a 7-year period, I believe that a good quality paint should last about 12 years in a normal household situation. So if you're not getting 12 years out of your paint, you're probably painting too much. Also, you don't really want to layer too much paint on your house. So you want to try to paint as little as possible, just for the fact that the paint will fail after it gets too thick, meaning it will craze and crack. Also, every time you layer chemistry, you set up problems. Because sometimes you don't understand what the chemistry is, the substrate that you're putting the paint over. So that is a reason to try to eliminate painting. Many times if I go to look at a house and I see that the color of the walls or the trim is a good color for the lighting conditions, or that it's in very good condition, it's just dirty, I will recommend to the client that they don't paint, that they clean the surface. Don't change the color unless there's a real good reason. And environmentally, that is the preferred choice. The less paint you use, the less waste you'll have that will go into the environment. So you want to make a strategy that's going to limit the outgassing in your environment. Use a paint that's going to last as long as you can have it last. And you're going to try to limit the buildup of paint on the surface. And that's particularly important on the exterior. But on the interior, it's also a real concern. So I'm not going to recommend any particular products. Most paint companies are now coming out with low VOC or no VOC paints. But just make sure that when you buy your gallon of paint, that when the colorant is added, that you aren't getting a totally different product, that you're actually still getting a low VOC paint. And just make sure it's a product that you've heard has a good life to it. There are some products that work a lot better than others. I like Benjamin Moore's Aura paint that's been out for about 4 years. And I'm recommending that to my clients, although it's not no VOC, it's low VOC, so it doesn't outgas a lot. And it covers very well, and you can cover, in most cases, with one coat. So not only are you cutting down on labor, you're also cutting down on the amount of paint that you're putting on the surface. So I would recommend that if you're considering using a paint product, that you look at what kind of product you're purchasing and what the quality of the finished job is going to be, and make sure that it's the color or the kind of quality for the atmosphere that you want. And then it will really be the greenest product that you can use. Most good quality paints don't model too much. It is true that you, by scrubbing or using a pumice type material or a soft scrub or anything that's going to be abrasive, it's going to probably chalk some of the paint and change the sheen. So if you have a semi-gloss, it might bring it down to an eggshell. But that is, you know, that's, I think, a choice, a decorative choice. It's not going to be consistent if you don't do a good job of doing the same technique over the whole surface. But cleaning can just be for getting rid of oils, getting rid of soils, and also then there'll be probably dark, you know, skid marks or black marks that you'd be trying to get rid of. You really want to start off with the mildest thing you can come up with. You really don't want to use anything too abrasive to start off with. You want to see how much dirt you can get off. What I find is interesting is that many people think cleaning is just painting over dirty walls. And really, that's not a good way to bond one paint surface to another. It really makes more sense to clean the walls first and see what you have, and then paint over it. Now, a lot of people don't want to spend that kind of time, and they think, oh, well, I'll just put a coat of paint over it, and then it will be clean. Well, it may be true that that might happen, but it is also true that if there's enough oil buildup, you'll be repelling the surface that you just put on. You might find that it bubbles or that it doesn't adhere well. So a good cleaning, but not leaving water on the surface before you paint, is a good idea. And it also just it cuts down on the amount of paint that you'd be using or putting in the lamp. Oil-based paint is the medium that holds the colorant is oil. It is, to my mind, the better paint for certain conditions like woodwork. It tends to outlive latex, but in this state, in many states in the country, oil is no longer legal. In Massachusetts, we are running out oil. They're not producing it anymore to be sold in the state. We're just running down the supplies of oil. But there is still oil available, and I think for wood trim, it still lasts almost twice as long as latex. But it does have more volatile organic compounds, and that's the reason they're outlawing it. It does work better in New England because of the shrinkage and expansion of wood over the seasons. So they've tried not to outlaw it and reduce the volatile organic compounds in it to be able to use in the conditions that we have, but it really is no longer going to be accepted. So my recommendation to clients is to paint oil as long as you can, because one of the reasons I suggest that is that I think is very conscientious about the environment is that you're going to be painting a lot less if you have a good substrate of oil paint on the surface. The latex is getting better. It's just not great. It's good, but it doesn't last more than 6 or 7 years. And what I mean by lasting, it tends to pull away from the surface. It scratches easily. It just doesn't maintain the level of surface that oil does. If they're both put on equally well, the oil will last a lot longer. Walls, latex is great. It's engineered for the kinds of plaster surfaces that we have, and it works very well. So the only time I recommend oil for walls is if you have a wooden wall, like a beadboard wall or centerbead board or something like that. Oil outgases, they're very obvious. You smell them. When you can know when you've been in a house that is outgassing oil compounds because it's very strong. And one good thing about that is you tend to ventilate that area to get rid of it, so it tends to dissipate a little better. One of the problems with latex is that it's so subtle that you don't notice it until you have a headache. And that's a very big issue with painters, because even though they're getting as much of an offensive situation from the compounds that are being outgassed, they're not recognizing it and they're not ventilating when they're using it. Now, they all dissipate over time. Better, I recommend for children's bedrooms and all bedrooms to use low or no VOC. You have less traffic in those areas, and so if the paint doesn't hold up quite as well, the benefit is that they're not outgassing. A strategy for using the products that are available now, you need to really look at what you're purchasing to make sure, if you think it's low VOC, that it is, and that you're using those products in the right places and under the right conditions and with the right color choices so that you're not overusing paint. Because that, I think, is one of the biggest environmental issues, is just the amounts of paint that are wasted and put into landfills. Color use that can actually change your perception of your environment and help with heating and cooling. All of us recognize ourselves that what warm colors are like and how they affect us. You want warm colors surrounding your peripheral vision and around you when it's cold. So if you are planning a room, an interior room, that you're going to be spending a lot of time in the winter, and you want it to be warm, and maybe it's not south-facing and it's north-facing, so the predominant light in that space is a cool light, you're going to want to pick a color for the walls that's going to radiate the kind of warmth that you crave. One of the things that was brought up by in the discussion about the windows was that we're cutting out the red light with low E glass and these high energy efficient windows. So that red light is what warms us and what we crave during the winter. As the light gets lower and as it is less warm and we're not getting less of the heating spectrum of light, we crave that color. And if you choose a color that has a red aspect to it, like if you're going to be using a yellow, it will have some red if it's slightly more orange than a yellow that's more on the lime green side. This is a bedroom of a teenage girl, and she just wanted a cozy space. This doesn't have a lot of light. It's in an older house, and she wanted to have a color that just wrapped around her that was warm in the winter. This is a house that's in Salem, and this is there's a series of bedrooms, and I'm going to show you some of the different ways you can approach a bedroom with color. If you want to encourage sleep, cool colors are great. They really lull us to sleep. What makes this a perfect choice for this room is that it's southern in its exposure. So this room gets a lot of very strong southern light. And so during the day when you're going through this space, this blue offsets the strength of that sun. It's well documented that warm colors tend to encourage us to want to eat and to be sociable. And you probably noticed that many dining rooms or many restaurants are very saturated warm colors. It's at that level of your peripheral vision when you're sitting at the table. It's just above the chair rail. So you still get that sense of a strong warmth that just raises people's blood pressure and allows them to feel energized and ready to eat. The color can actually change your physiology. It affects us in subliminal ways that we're not necessarily aware of. Here's a dining room that is in a house that was a summer house. And all of these windows face out to southern exposure. People in general love wood as a product indoors. They just will many times opt for a wood surface, many times over paint. And one of the reasons for that is that quality of red light that gets cast from wood.